Let me introduce a historic story. Do you know Han Xin? There's a famous story about him. It's Han Xin counts soldiers. This is the story. When Chu and Han were fighting, once Han Xin was walking on a narrow road with his soldiers. At that time, Chu armies were chasing them, and the situation was very critical. At that time, Han Xin was not sure about how many soldiers did they have, and have no space. Enemies were chasing, and there was no time to reorganize the troop to see how many soldiers were there. At that time, Han Xin came up with an interesting method. He told the soldiers not to worry and asked them to stand in line of 3 to see how many were remained, and in lines of 5 to see how many were remained, and in lines of 7 to see how many were remained. 2 were remained when stood in lines of 3, 3 were remained when stood in line of 5, 2 were remained when stood in lines of 7. His adjutant reported that there were a total of 1,052 soldiers. Han Xin shook hands and disagreed. He said, "We have 1,073 soldiers. The enemy fewer than 500 soldiers, and we have more than 1,000. Meanwhile, we are in the dominant position. We must be able to beat them." Then the soldiers were in high morale, and they defeat two armies soon. This story seems strange, and how could Han Xin know the number of soldiers? Simply by lining up soldiers and looking at the remainders. Actually, there is a similar problem. In the mathematical class of Sun Zi, in the mathematical classic of Sun Zi, there is such a problem. There are something, but we don't know how many. Count by 3, 2 are remained. Count by 5, 3 are remained. Count by 7, 2 are remained. How many are there? What's the meaning of this problem? It says that we have a number x, such that x divided by 3 have 2 left. X divided by 5, the remainder is 3. X divided by 7, the remainder is 2. What's the number of x? This is actually the congruence equation in elementary number theory. We could write them in the equation such that x equal to 3a plus 2, x equal to 5b plus 3, x equal to 7c plus 2. Then Han Xin calculated the value of x very fast, and he got the number of his soldiers. How did Sun Zi solve such an equation in his mathematical classic? We will start from a simple problem. Let's look at the problem in Sun Zi mathematical classic. Solve it by enumerating at first. For example, it requires x divided by 3, we left 2. Let's list all the numbers with remainder 2 and divided by 3. We also list all the numbers with remainder 3 when divided by 5. Finally, we list those with remainder 2 when divided by 7. When we list all of them, we will discover some common numbers which satisfy all of them. The smallest common number is 23. But I think that Han Xin mustn't use such a method to get the answer. Do we have any better ways for this problem? For example, can we find such a number by the method of construction? We would discover that here we could consider some multiples of 5, some multiples of 7, and then add some remainders. For instance, we would set S be the common multiples of 5 and 7. How many common multiples of 3 and 7 have remainder 1 when divided by 3? One common multiples of 5 and 7 such that it divided by 3, the remainder is 1. It's 70. It means that if we multiply this number by 2, it must be divisible by 5 and 7, but it divided by 3, we left 2. So it satisfies the first equation. For the other equation, 5b plus 3 and 7c plus 2, it contributes nothing to the remainders. So we could use this idea. For instance, we use t to denote multiples of 3 and 7, which divided by 5 have 1 left. We multiply t by 3, it is 63. This means that it's common multiple of 3 and 7, but it divided by 5 left 3. So it exactly satisfied the second equation. Then I could keep calculating h, which is a common multiple of 3 and 5. Well, it divided by 7 left 1. This time we have h times 2 equal to 30, which is a common multiple of 3 and 5, and it satisfies the third equation, which is 7c plus 2. So now I want to construct a number which is divided by 3, left 2, divided by 5, left 3, divided by 7, the remainder is 2. We could have 2s plus 3t plus 2h, which is equal to 233. As our design could guarantee that when divided by 3, its remainder is from the first part. When divided by 5, its remainder is from the part of 3t. When divided by 7, its remainder is from the part of 2h. So this number must satisfy this congruence equation. Of course, 233 is only one of the numbers which satisfy. What if we want to find the smallest one? As the smallest common multiples of 3, 5, and 7 is 105, we could keep subtracting 105 from 233, and finally we get the smallest number, which is the same as we got by enumeration. 233 minus 105 minus 105 is equal to 23. Now let's answer the problem on Sunzi's mathematical classic. There are something, but we don't know how many. Count by 3, 2 are remained, count by 5, 3 are remained, count by 7, 2 are remained. How many are there? There are 23. Now let's see what did Hanxin did. Actually, Hanxin remembered those common multiples, and then he simply used the multiplication to find the appropriate answer, which suited the size of the MA.